For 4 minutes on March 14, 2025, the sun went silent. Not dark, not cooler, silent. Every instrument tracking the solar wind, the million-mile-per-hour stream of charged particles shielding Earth from cosmic radiation, registered the impossible: 0. GPS signals faltered, threatening navigation for flights and ships. Power grids braced for surges. The ISS crew sealed their storm shelter, fearing an unprotected radiation spike. But what the cameras captured in the corona raised an even deeper question. To grasp the impossibility, consider the sun's constant output. The solar wind is unrelenting. 1 million tons of plasma, protons and electrons ejected per second, accelerated by the star's magnetic field to supersonic speeds. Imagine a perpetual stream, active for 4.6 billion years. This wind forms the heliosphere, a protective bubble deflecting interstellar radiation and shaping Earth's magnetosphere. Satellites rely on it for stable orbits. Communication networks depend on predictable ionospheric conditions. Astronauts count on it for radiation shielding. What if that stream vanished? March 2025 marked the solar maximum's peak intensity, with sunspot activity doubling forecasts. NOAA's Space Weather Prediction Center had issued 17 alerts in the prior month alone. Yet when the sun abruptly ceased, no model could account for it. The anomaly began at the Advanced Composition Explorer, ACE, stationed at the L1 Lagrange point, 1 million miles sunward of Earth, providing a 1-hour storm warning buffer. At 11:42:18 UTC, ACE's plasma sensor logged solar wind velocity plummeting from 480 kilometers per second to 12 in under 6 seconds, then 0. NOAA controllers in Boulder suspected sensor failure, but what followed ruled that out. 18 seconds later, the Solar and Heliospheric Observatory, SOHO, confirmed the drop. Then the Wind spacecraft. Then STEREOA. All solar wind monitors registered nothing. 11:43 UTC. The Daniel K. Inouye Solar Telescope in Hawaii detected visual anomalies in the chromosphere. Straight-edged geometric shadows traversing the sun's surface, defying known magnetic patterns. Not sunspots, not prominences. They advanced against solar rotation. But why? 11:44 UTC. GPS satellites reported timing drifts, eroding precision for global navigation and prompting air traffic backups. Europe's Galileo system triggered recalibrations amid space weather protocols. 11:45 UTC, ISS radiation alarms activated, not from elevated levels but from the absent solar wind exposing the station to a 3% rise in galactic cosmic rays. Commander Jessica Whitmore secured the shelter and queried Houston. "Confirm solar wind reading. Are we facing a Carrington-class event?" Houston replied, "Stand by. We don't know." Frame by frame, spectrometers noted 200,000 Kelvin drops along shadow edges, impossibly sharp for plasma dynamics. 11:46 UTC. The wind resumed, restoring normal velocity and density within 40 seconds. Magnetic fields aligned as before. Yet one lingering signature persisted: a 15 nanotesla dip in Earth's dayside magnetic field, unexplained without a solar trigger. With solar wind pressure gone, Earth's magnetosphere relaxed, like a balloon losing tension, inducing currents in extended conductors. At 11:43 UTC, Quebec and Norway transformers logged geomagnetically induced currents at 70 amps per phase, atypical without solar input, risking grid stability worldwide. 17 low Earth orbit satellites entered safe mode, rotating panels to minimize cosmic ray exposure as radiation monitors flagged the uptick. But a complication arose. Their magnetometers sensed a weakened field, compounded by GPS errors, disrupting orientation calculations. One classified NRO satellite lost attitude lock for 90 seconds, drifting 140 kilometers off course before recovery. NASA's Deep Space Network lost telemetry from 8 distant probes, MRO at Mars, Juno at Jupiter, New Horizons in the Kuiper Belt, as Earth's ionosphere thickened, bending radio paths. Operators adjusted manually. Deeper in the data lay the inexplicable. The Parker Solar Probe, 12 million kilometers sunward on approach, captured magnetic fields unlike any solar norm, straight, parallel, uniformly aligned, like filings around a bar magnet. Solar fields are inherently chaotic, twisted and reconnecting. This order suggested something imposed. But from where? "72 hours post-event, NASA assembled an interagency panel with NOAA, ESA, JAXA, and US Space Force, sifting 11 terabytes of data. 3 theories surfaced. Theory 1, instrument artifact. Synchronized failures across spacecraft could stem from a shared electromagnetic interference, like a subtle pulse affecting similar magnetometers. Evidence. Common sensor designs invite resonance issues. Counter, ground telescopes, using distinct optics, observed identical shadows, ruling out widespread hallucination. Theory 2, unknown magnetic structure. A rare coronal reconnection might have diverted wind from the ecliptic, creating a transient hole, echoing documented solar wind dropouts tied to coronal mass ejections. Evidence. Solar maximum fosters novel field complexities. Counter. Diverting all wind demands implausible energy. It fails to explain Parker's uniform lines or counter-rotational shadows. Theory 3. External interaction. An unobserved phenomenon or object might have transited the inner heliosphere, imposing a disruptive field. Evidence. The geometric shadows, abrupt timing, and synchronized effects align with an imposed order. Counter. Such a field would rival a neutron star's, detectable years prior, yet no gravitational or occultation traces emerged. No anomalies recurred. The Sun stabilized to typical maximum patterns. Forecasts resumed. Yet those 240 seconds exposed a gap. Our systems, GPS for navigation, grids for power, shielding for spacefarers, hinge on solar predictability. 4 centuries of observation, 5 decades of probes, and still the Sun holds unknowns. On March 14, 2025, the Sun went silent. Models shattered. The cause remains unresolved. If you seek a reconstruction of a Mars colony isolated during solar conjunction, facing a self-sustaining crisis, that's next. More forensic breakdowns of space systems failures weekly. Subscribe for analyses unavailable elsewhere. I am the cartographer. This is the Atlas.